Okay, so today we're going to go beyond 1/2, 1/3, and 1/6 when doing our hands-on equation fractions. And here's the exercise. This is still lesson 7 honors. Okay, exercise 1, solution 1. So let's consider an equation in which the fractional parts of the unknowns are expressed in terms of unit fractions other than 1/6 y, 1/3 y, and 1/2 y, with whole number constants. For example, let's see how we can apply the strategies we have learned to solve an equation such as the one below, which I'm going to write, in which the fractional parts of the unknowns are expressed in terms of 1/4 y and 1/8 y, having the denominators of 4 and 8. So here we go. This is what I mean by that. 3/4 y, you can see that's broken up into 4, something that we have not worked with yet, plus 2 is the same as 8y plus 20. Since the common denominator of 4 and 8, these are the denominators here, 4 and 8, we will consider the unknown y as being partitioned into 8 equal parts. So for example, this to you. So we need to get 8 out of 8 to equal 1y. So we're going to break, go again, my pen not working. There we go. Okay, so we have, it's going to be 1/8. It's going to be partitioned into. So that means that 1/8 y is going to equal y, and that's the same there. So y is going to be equaled, partitioned, into 8 pieces. Okay, so in order to get one whole y, we need 8 out of 8 that I have above. And I wish the pointer was always there where you can see it. 8 out of 8, and then y is the same as 8 pieces. So let's go ahead and look at that a little bit better. So we need to break this up into 8 pieces. We have the 3/4 y up into 8 pieces. Let's go ahead and do that. So in order to get that 4 to the 8, I multiplied it by 2. Okay, so now we can see that what we do to the bottom, we must do the top and vice versa to keep it equivalent. So 3 times 2 is 6. 4 times 2 is 8. Now we can see that they have a common denominator. Okay, so now we're going to go plus the y plus the 2, and 5/8 stays the same because it's already broken up into 8 pieces, our common denominator. So here's our equation. And now what we're just going to talk about is keeping them into their parts, getting rid of our common denominators because they're the same now. So for example, we can rewrite this as the given equation into parts. So we can see we have 6 of the parts, and then we know we have, this would be the same as 8 out of 8 y. So we have 8 of those parts here, because that gives us one whole of the y, plus the 2, and we see here we have 5 of the parts, plus the 20. Okay, so let's go ahead and go down. Some more space, and let's do our next step. Our next step is that we need to combine the like terms and subtract the 5p from both sides of the equations, because what we want to do is we have to add all the like terms, and here's a like term, here's a like term, and here's a like term. So we got to get those on one side of the equation and our constants on the other. So let's go ahead and do that. First, I'm going to add these like terms here. I know that 8 plus 6 is 14. So we have 14p plus 2 is the same as 5p plus 20. So now I can still see that I have a like term on this side that needs to come over here. And the constant needs to go. Let's can't see what I'm doing because my cursor is not working. So let's go ahead and just take away this 5p from this side. And whatever I do to this side, I must also do to this side. So now we're going to have 14p subtract 5. I'm going to be left with, got it, 9. I'll do that slowly if you need me to. 14 subtract 5. I guess we don't need to do that. It's just 9p. You guys can figure that out, hopefully. Plus 2 is the same as 20. So I still have my constant on this side, so I need to get rid of it. So I'm going to take it away from that side. And now you can see that we are left with 9p is the same as 18. Okay, so we still have to get rid of our 9 on this side because we have our coefficient here. So remember, this is multiplication, and to undo that, so I only have 1p on this side, I would need to divide it. And 9 over the 9 is the same as 1. So what I do on this side, I need to do on this side. So now I'm going to be left with just the p like I wanted to. And 18 broken into 9. You can see that is going to be 2 wholes because 9 times 2 is 18. So now we can see that the answer is p is going to be equal to 2, or is the same as 2. So now we need to actually do our check. So we're going to rewrite the equation. This equation right here, let's go ahead and rewrite that. So page. Let's go ahead and do that. So let's write it as 6p plus 8p plus 2 is the same as 5p plus 20. And so remember, our p equal 2. So wherever there's a p, you plug in the 2. So let's do that now. So we replace this p with 2. Okay, so we can see here that we're going to go have 6 replacing, remember, with 2, the p, plus 8 times 2, because we just replaced the p with 2, plus 2, plus 20. Okay, so we replaced all the p's with our 2, plugged in. So we can go ahead and do the multiplication and the addition. So 6 times 2 is 12. 8 times 2 is 16. And it's important to make sure your multiplication is right because your whole problem will be wrong. And that's usually where kids make mistakes, is on their multiplication. So I'll be honest with you, I did 8 times 2. I wrote down 18 last time and I had to redo the video. So make sure you're slowing down and making sure your multiplication is right. Plus 2 is the same as 5 times 2 is 10 plus 20. And now we can go ahead and add those together. I can see that I'm going to do this side first because it's easy. It's going to be 30. 20 plus 10 is 30. And then here we have, I'll add up all my units, 6, 7, 8, 9, 10. Then I have one more 10 here. So it'll be 1, 2, 3 tens, so it's 30. And you can add that up any way you want to. So we can see that this checks out. I have 30 on this side and 30 on this side. So our equation board is balanced. So we did the problem correctly.